Have with us Dr. Gaurav Dixit. He's a joint faculty in the Mehta Family School of Data Science and Artificial Intelligence and a core faculty in the Information Systems Group, the Department of Management Studies at IIT Roorkee. So Gaurav's research focuses on applied machine learning and deep learning in social media, web recommender systems, and finance domains, business value of IT or analytics, IT use and user characteristics in e-commerce, decision-making in sustainability, ICT, e-commerce, e-governance domains. Dr. Gaurav's research articles have been published in leading academic journals and conferences. Gaurav started his professional career at HP as a software engineer, and further he worked in different firms. Previously, Dr. Gaurav has taken courses as a visiting faculty at IIM Indore, NIFT Bangalore. He earned his doctoral degree in 2014 from IIM Indore. So he's an expert in this area. So we are really lucky and glad to have Dr. Gaurav with us. Thank you very much, Dr. Gaurav, for kindly accepting our invite and for joining us today. We are really, glad to have you for this session. We really hope that it will be highly beneficial to all our participants, and we are eagerly waiting to hear you. Thank you once again on behalf of IIITS Sri City as well as the organizing committee. I welcome you to the session and expressing our sincere gratitude for being here. Thank you, and over to you, Gaurav. Thank you so much.
Thank you, Dr. Arun. Am I audible?
Yeah, you are audible.
Yeah, thank you. Thank you for such a nice introduction, and thank you for inviting me for this FDP. So, let me share my presentation. Is it visible?
Yeah, it is. Yes, it's visible.
Yes. So thank you once again. And title of my lecture is an overview of multi-criteria decision making. So what I'll do, I'll go through some of these items, like what is multi-criteria decision making, why we actually do this, why we do MCDM, what are the branches, what are different school of thoughts that are there with respect to MCDM, the classification of MADM. So this is, I'll talk about this later, during the lecture, that typically in business context or management context, we typically, especially from the planning and policy perspective, we focus more on MADM. And when it comes to technical or engineering aspects, then the focus is more on MODM. So all those things we'll be covering. And typical MCDM problem, how it is formulated. And then there are certain extensions to classical MCDMs that are there. And then we'll look at MCDM process, the typical steps. And we'll also do, take one of the popular MCDM, which is, if we look at the whole volume of research papers which use MCDM methods, then we'll find that AHP is more frequent there. So we'll look at this one and a Python implementation of this. Right. So in between, if there are any questions, please feel free to stop me, and we can have an interactive discussion in that way. Dr. Arun, I have 1 hour, right, for this presentation. Am I correct? Okay, so moving forward, so there are two terms here: mono-criterion methods and multi-criterion methods. So there can be decision-making situations where based on just one important factor, just one criterion that is there, we might make our decision-making. We might conduct our decision-making. So for example, given a plan is a single and specific objective. So cost benefit analysis typically, in many situations we typically, stop at, typically, go by cost benefit analysis. So in those situations, more often than not, we are dealing with single and specific objective. Then a simple cost benefit analysis and other similar kind of analysis would suffice. Now, but there can be situations where we might want to take into account various dimensions of interest, and there might be interplay between those factors, those dimensions. So interplay between multiple, often contrasting. Right? So if everything aligns well, then again there is no problem. Just because of multidimensionality of the situation, just because of that, there won't be an issue. So there has to be, if there are any issue or uncertainty or conflict, then it becomes more complex, and that is where the multi-criteria methods are going to be really helpful. So often contrasting objectives and different decision criteria and methods. So these are the two situations, right? Now, if you look at the literature-driven definition of multi-criteria decision making, then it is defined as the study of methods and procedures by which concerns about multiple, usually conflicting criteria can be formally incorporated into the management planning process. Though this definition, particular definition, talks about the management planning process, but it could be any decision making process. So any decision making process where we are dealing with multiple and typically conflicting criteria, then the decision making itself becomes quite complex and complicated. So this the whole area, multi criteria decision making, is actually a study of that. What are the methods, what are the procedures that we can develop and adopt and apply, so that we are able to deal with these kind of decision making scenarios. The second definition on MCDM is deals with mathematical theory, methods, methodological issues, and case studies, which includes applications for decision process where multiple criteria, which could be objectives, goals, to different terminology sometimes exist because of classification also. Not just these terms might not necessarily be being used interchangeably, but because of the classification or MCDM, which we'll see later in the lecture. So objectives, goals, attributes, have to be or should be considered. Then this particular area, MCDM, deals with all those scenarios. Now, slide is visible, right? They're moving, right? No. My slide is visible. Can someone just inform?
Yes, your slide is visible.
Right. Okay, so now if we look at a simple definition of MCDM, it refers to making choice of the best alternative from among a finite set of decision alternatives because of multiple, usually conflicting criteria. Right. So this is simple. Essentially, we have a number of alternatives and the number of decision alternatives, and then we have a number of conflicting criteria. So essentially, it's in a way, for rough understanding, we can say, it's sort of mapping, right? Depending on those conflicting criteria, how we can arrive at, or how we can select the best alternative, or how we can order them, right? So MCDM is essentially entails into solving those kind of decision problems. Now, why we need MCDM? As pretty much visible from the definition itself, but to emphasize that point even more, there is increasing complexity of engineering and management environment. And so at times it is difficult for an individual decision maker to make decision, because one decision maker might not have all the experience that might be needed, because there could be multiple aspects that could be associated with those decision making tasks. So therefore, at times you would require the wisdom of multiple decision makers and formulate a one group judgment. So complex environment, whether engineering or management environment, and then one decision, the wisdom of one decision maker might not suffice, or we might not want to rely on just one decision maker, and we want to quantify the wisdom of multiple decision maker and then make a decision. So in all such scenarios, MCDM methods, the MCDM area helps us in solving all those decision problems. So typically, the objective of MCDM is select the best alternative from a set of candidates, or rank or prioritize alternatives into a preference pre-order. So most of the problems that are being addressed by MCDM, they are very similar at a higher level. They are very similar. You are selecting best alternative, or you are prioritizing them, or you are sorting them. But essentially, the process that will entail into solving these different types of problems would be would have a lot more similarity. Right. So by evaluating a finite set of alternatives based on two or more criteria, we are trying to find out the best alternative, or we want to rank or prioritize the alternatives that are given to us. So there are two main branches of MCDM. So first one is multi-attribute decision making. The second one is multi-objective decision making. Right. So let's have a look at the difference between these two, MADM and MODM. So in MADM, the criterion type is typically called attribute, and MODM, it is typically referred as objective. The property, so what this criterion is about, so it is in case of MADM, it is more implicit and not directly related to alternatives. So therefore, it is more subjective in nature, it is more perceptual in nature. So when we talk about MADM, the criteria, this slight differences between MADM, this is visible, right?
Yes, sir.
It's visible. I mean, I have two of my students, they are not able to see it somehow. So
Is it visible, sir?
MADM, so right now I'm presenting these differences between MADM and MODM. So is it visible?
Currently, you are in multi-criteria decision making.
Oh, I think
MCDM.
There is some lag or something. I don't know.
And your slide is not in presenting mode, sir.
Oh. See. Now is it visible? Differences between MADM and
Yes. Now it is clearly and in presenting mode also.
Okay. Okay. So previously, let me do a very quick, brief of this. So this was flow of presentation. We talked about the monocriterion and multi-criteria methods. Then definitions of MACDM. So the main simple, point here is that we are trying to select the best alternatives from a finite set of decision alternatives given multiple and usually conflicting criteria. So we talked about that individual decision makers going to be difficult. So we need multiple decision makers, and therefore we need a process so that we are able to quantify, their wisdom. So typically the tasks are, select the best alternative or rank or prioritize alternatives. So the tasks are quite similar, but the tasks, might look slightly different, but the procedure that is typically adopted is, it has a lot more similarity. Then these are the two main branches of MCDM: multi-attribute decision making, and then multi-objective decision making. So now, we were looking at the differences between these two. So when we say MADM, the criterion type is going to be attribute. And when we say MODM, then the criterion type is going to be an objective. So what is the property of this criterion? How we can understand this? So this is more implicit and not directly related to alternatives. This is more subjective and perceptual in nature, right? So more subjective and perceptual. When we talk about MODM, it is more explicit and directly related to alternatives. So in ammonium, it is more explicit and directly related to alternatives. So there is clear difference between what we face in ammonium and the situation that we decision making situation that we face in ammonium. Then constraints fixed and combined with attributes. So constraints are actually subsumed by the attributes, and that is why they also become subjective and perceptive in nature. But in case of ammonium, these constraints can be changed, modified, and they are explicit in nature, so they can be clearly specified. When we talk about the alternatives, so they are going to be finite and discrete. So there are going to be 3, 4, alternatives, right? Let's say we are trying to, location facility problem, production facility problem. We'll take a look at that. Then, we'll create a finite set of alternatives, 4 or 5 locations, which we can pick to invest for our production facility. So the finite set of alternatives are going to be there. But when we talk about ammonium, so infinite and continuous alternatives can be there. So essentially, if you really notice, this space is continuous space and continuous decision space, and this space is more discretized decision space. So because of the subjectivity and higher level of perception that is involved in MADM, typically they are used in planning and policy tasks, where things are more complicated and more complex in terms of both constraint and the criteria that we need to consider. While in MODM, it is typically, we go more, we look at more technical kind of problems, so design and optimization tasks. For example, traffic signal, traffic route planning, highway, and all those, those kind of planning that might be required. So more in simpler terms, we can understand this like more of a continuous decision space, and this as a more of a discrete.
Sir, it seems your voice is not audible to us. Gaurav sir, are you there?
Hello. Yeah, sir is here only. Just there is some technical glitch. He is joining. Just a
Okay.
minute. Okay.
Am I audible and the slide is visible?
Yes, sir. Yes, sir. You are audible and your slides are visible.
Okay, so there was some internet, internet got disconnected. So,
Yes, sir. Yes.
sorry for that. Right. So I was saying that I hope everyone was on this slide. So to explain a bit more about MADM and ammonium, so we'll start from, we'll take understanding from this taxonomy. So MCDM methods, we can divide them into formal and simplified methods. So simplified methods can be used by decision makers when they don't really have the time and they are not willing to bear the cost and all that. We'll go with the formal methods. So then they can use summary charts, checklist that based on their experiences over a period of time they might have formulated. So they can go with that. If decision makers are willing to invest into formal methods, right? They want more, they want more of a formal analysis before they arrive at their decision. Then within formal method, there are two, classes: continuous decision space model and discrete decision space models. So discrete one, I spoke about, we refer them as MADM methods, and the continuous decision space model, we refer them as MODM methods. Now within MODM, you are familiar with linear programming, goal programming. So goal programming is the really that can be put there in MODM, because there are going to be multiple goals that can be handled, and there are going to be certain target value that decision maker would like to be achieved, right? So this is continuous decision space model. Then within MADM methods, within this discrete decision space methods, there are two categories: full aggregation methods and the partial aggregation methods. Now we are going more into the procedure. So this is more of a procedural difference. There are different school of thoughts: American school of thoughts and European school of thoughts. So they have gone their own ways about developing their own kinds of methods. So typically, American school of thought, they have gone with full aggregation methods, and the European school of thought, they've gone with the partial aggregation methods. So these are the examples: MAUT, ASP, BWM. These are some of the examples of full aggregation methods, while for partial aggregation methods, selector, Promethe are there. While this taxonomy is more for an understanding purpose, so this might not be totally exhaustive of everything that is nowadays there under NCDM, but it gives us a good understanding, good overview of different types of methods that are there. Now let's look at full aggregation methods. So further classification of MADM, full aggregation methods and partial aggregation method, and what is the difference? In full aggregation methods, this is basically coming from American school of thought. So they assume that complete preference systems is possible. That means, given all the criteria and alternatives that are there, the decision makers are able to give their preferences for different alternatives with respect to all the criteria that are there. So they can completely elicit or evaluate alternatives considering all the criteria and all the alternatives. So full or complete preference system is possible. So that is the assumption behind most of the methods that are there under full aggregation category. So essentially, if the complete preference system is possible, then they go one step up, where they convert or translate a multi-criteria scenario into a mono-criterion scenario. So how they do that? If full aggregation is possible, because complete preference system is possible, so full aggregation is possible, and that means all the alternatives with respect to all the different criteria, they can be evaluated by decision makers. Therefore, we can also arrive at a single global score. So the moment we have a single global score, we essentially translate the multi-criteria scenario into a mono-criteria scenario, because we got one score, and using that score, we can make recommendations from those set of alternatives. While partial aggregation methods, this takes a different school of thought. They say that complete preference system might not be possible, because they introduce the notion of incompatibility. So there can be certain criteria, certain factors which might not be easily compared, right? And therefore, there is this notion of incompatibility is there, and there is heterogeneity among criteria. So therefore, complete preference system might not be possible. So in other words, decision makers might not be able to convey or might not be able to give their evaluations or preferences for all the criteria and alternatives, right? So maybe for some of them they can give, but maybe not for others, because they might be incomparable, there might be heterogeneity, many other such things. Right. So full aggregation might not be possible. So therefore, partial aggregation, that's why the name. So partial aggregation is the only possible thing. So that means if the full aggregation is not possible, then we won't be getting a single global score, because everything cannot be accounted for. So we cannot have a single global score. So notion of outranking or dominance is then formulated, right? So now coming back to full aggregation method. So here the next important point is that these methods are able to provide full compensation between criteria which can be controlled by. So full compensation between criteria is possible. That means if one alternative is not doing so well with respect to one criteria, and it is doing very good with respect to some other criteria, then compensation is possible. That overall its prioritization might, or its prioritization might go higher, right? So that is a more of a compensatory approach. So if you are not doing well in one particular criteria, you might do well on other criteria. So overall, your score improves, can still improve, and that is possible because we are having a single global score. So full compensation is possible. Now, at times there might be scenarios where there might be an alternative which is doing well across all the criteria, but there is another alternative which is not doing so well for one or two criteria, but it is doing very good on one or some other criteria, and overall the score goes up. So which one we should be preferring? The one alternative which is doing well across criteria, across all criteria, or the one which is doing well across just one or two and overall improving its score? So to control those kind of scenarios, non-linear aggregation or thresholds can be actually implemented. Coming back to partial aggregation, here partially or totally non-compensatory approach is to be followed, because it's partial aggregation, so it's not really going to be possible. And further, we are using notion of outranking or dominance, which is not exactly the same equivalent thing that we are doing in full aggregation. So a low score against one criteria cannot or can only partially be compensated for by a better score against another criteria. So it can be partially compensatory or totally non-compensatory when it comes to partial aggregation method. Now, because it's compensatory, so full aggregation methods are more like trade-off coefficients. The weights that we get in full aggregation methods, they are more like trade-off coefficients, because compensatory approach is being followed. So the marginal contribution is being controlled. So the way method is quantified, the contribution is being controlled, and it is more like a trade-off coefficient that we get. While when we talk about partial aggregation, because we are essentially just at a high level, we are looking at just the outranking or dominance of one criteria over another, then essentially we are only looking at importance coefficient and essentially the influence of it. It's more like multiple linear regression, where we include all the models in one go versus a model where stepwise we are accounting for variable one by one. So that kind of difference is there. Right. So strength of mutual preferential independence property. So this property is also there, mutual preferential independence. So the criteria that are being considered, so to what degree they are independent of each other, to what degree they can be evaluated or they can be compared, or independently. So that is also important in this. So influences the choice of linear or complex aggregation form. So if it is totally independent, then we can go for linear form itself. But if there is some sort of dependency or weak independence is there, then maybe we can go for complex aggregation forms. So that also one has to look at when it comes to full aggregation methods. Now let's look at the typical MCDM problem, how it can be formulated. So MCDM problem is mathematically modeled as a decision matrix. So let's say for an MCDM problem with m distinct alternatives. So let's say these are the alternatives A1, A2, AM, and we have n criteria, C1, C2, Cn, and k decision makers. So decision matrix D for k decision maker can be expressed like this: dk C1 of A1, and it goes up to n criteria is there, so Cn A1 and C1 of AM and Cn AM. So where where CI of AI represents the level of achievement of an alternative A with respect to criterion CI. So how well it is doing, how well that particular alternative is doing with respect to a given criterion. So that is being, measured here. So one way or another, it might be, sometimes the input might be taken from decision makers. Sometimes some data might be there which can be used to take that kind of input. So values of the criteria for alternatives may be real, interval, fuzzy numbers, or qualitative. So the way this value, which is indicating the achievement of alternative with respect to criterion, it is allowed any kind of data, real, interval, fuzzy numbers, qualitative. Right? So why fuzzy numbers? Sometimes decision makers might not be able to precisely specify their evaluations. So those fuzzy scenarios, fuzzy numbers, fuzzy set theory, and all that can be used. Sometimes they might be more comfortable with giving interval data instead of the real values. Right? Sometimes only qualitative evaluation might be possible. So all these different types of evaluation, therefore different types of data might come from decision maker or other sources, and therefore accordingly, it can be used in the methods. So to give example of selection problem, because there are 2-3 typical problems that are typically addressed using MCDM methods. Selection problem, ranking problem we talked about. So typically the aim is like determine the overall utility of an alternative under study with respect to given number of decision criteria. So essentially we are trying to determine the overall utility of an alternative under study with respect to given number of decision criteria. So linear aggregation, as I talked about, it can work if criteria satisfy mutual preferential independence property. Otherwise, we can go for non-linear, aggregation forms. So simply, we can say that need to maximize the following utility function: U of Aj is equal to 1 to n, and Wi Ci of Aj. Right? So this can be a cardinal number, and Wij, these are the set of values that it can take, weights can take this interval 0 to 1, and then total sum should be 1. So this kind of formulation can specify our objective here. So overall utility in this way can be expressed, right? So the alternative for which this utility would be higher can actually be selected. So simply in this way, this can be formulated. Similarly, for ranking problem, here MCDM needs to determine a preference pre-order, because we are prioritizing things, we are prioritizing alternatives. Therefore, we need to come up with the output or the recommendation should be some sort of ordering of alternatives. So this preference pre-order for A1, A2, AM, these alternatives with respect to criteria. So essentially, there exists an order of this form, right? So some with respect to a criteria and with respect to alternative, so it is going to be greater or approximately equal to this one, and this is how the list can be made. So essentially, this I1, I2, IN that we are depicting here, this is going to be a permutation of all the alternatives that are there. Right? So in this way, ranking formulation can be understood. Now there are extensions to classical MCDM. So there are, as I talked about, there can be issues with respect to imperfect knowledge from human evaluations. We might be modeling complex real decision problems, right? So the information might not always be crisp. That means essentially precise. So it might not always be precise. It will be more fuzzy information. That means it might be more incomplete or vague due to human evaluation, because decision makers, if the data is coming from decision makers, which is more likely the case, then it might be incomplete or vague, or they might not be able to specify or able to give crisp information. So when we use crisp information, the methods are referred as MCDM, or the two categories, two branches, MADM or MODM. If we are using fuzzy knowledge, then we can call fuzzy MCDM or fuzzy MADM or fuzzy MODM. So these are important extensions, right? because of the complex scenarios that we typically face. So there can be fuzzy number based MCDMs where, for example, triangular fuzzy numbers can be used to specify the the evaluations. Similarly, intuitive fuzzy set, that is an extension of classical fuzzy set, that can also be used, which considers membership, non-membership, vegetation function, and all that. So these are all extensions. Now, if we look at the MCDM process as such, then first step is typically going to be the structuration of the problem. That means we structure a decision problem, we specify the alternatives, we generate the alternatives, the criteria, we need to identify the criteria that are important for the evaluation of the alternatives, or the alternative should be evaluated with respect to those criteria, those factors, and then performance table, how well the alternatives are doing with respect to those criteria. So all this we need to generate or produce or identify. So that is called structuring of the decision problems. We start from this point. Then preferences, articulation, and modeling. So we determine criteria, importance, integrated information depending on different MCDM methods. So value, utility, function, threshold. So these terms that are mentioned here, they might belong to different MCDM methods. So preferences, articulation, and modeling. So whatever the input that we have received from decision makers and other sources, then that is through a particular procedure that is then modeled, right? Then we do aggregation. That means once the modeling has happened for each of the alternative, then given the number of decision makers that might be there, there might be two levels of aggregation. One at the uh, alternative global score, then another, there might be more than one decision maker, so another aggregation layer can be there, and then we make the recommendation based on the aggregation previous steps. Now this is another slide where I'm trying to present a picture here based on the input information requirements. So again, this might not be very exhaustive, but for an understanding point of view, this gives an idea about what kind of methods are there, what kind of scenarios are there. So for example, decision makers, sometimes they are asked to make pairwise comparison. So information on criteria as per the structure of that method uh, is taken from decision maker. So for example, how two alternatives compare to each other. So AHP, ANP, VWM, so these kind of methods, they do something similar to this. Then there are outranking approaches, outranking school of thought. So there are information on criteria, thresholds, preference function. So this is more like partial aggregation approach we talked about. So it's more like full aggregation. This is more like partial aggregation. So here, a lot more information is required from decision makers. Right? These are the methods which fall in this category. Then there's goal and reference point also. So they all in this also, these two methods fall tops because so information on criteria from decision maker and numerical data might also be there. Here, distance of a solution from the ideal point, these kind of procedures are there. Right? So you can see, three very different way of taking information and then processing that information should be visible in this. Here, decision makers' involvement would be much higher because they will have to do a lot more pairwise comparisons. Here, the involvement of decision makers would go down because initially they will have to specify the criteria weights, and then after that, the more mathematical process, distance-based process will take over. Here again, they will have to specify different types of information. So different kinds of approaches and different kind of input requirements can be there. Now these are the popular classical MCDM methods, AHP, Electro. So if you analyze the volume of papers which use MCDM as a methodology, so these are some of the methods which would appear more. Now let's take one as an example. So let's take AHP, analytic hierarchy process. So here, let's say we have a decision-making problem consisting of M alternatives and N criteria. So because pairwise comparison method is adopted in this, So because n criteria is there, so if we just we start with the criteria, then n cross n pairwise comparison matrix NC2 on a 1 to 9 scale, those many necessary comparisons would have to be made. So it's slightly time consuming and exhaustive for the decision makers. In comparison, as I said, Topsys and Vicar might be requirement from decision maker is on the lower side. And the second step is consistency check. So because there might be number of, let's say there are 20 criteria, so 20 by 20 matrix is going to be there. So decision maker, might not be very consistent in his evaluations of the, criteria or alternatives. So inconsistencies might appear. So how do we check those inconsistencies and whether they are within tolerable or acceptable limit or not? So that we need to quantify. So consistency ratio is there, that is typically used to check for consistency, and if within the limits, then further analysis can be done. So compute the priority vector of criteria in this. So there are three approaches: eigenvector method, normalized, and geometric mean method. So typically this one is more preferred because it can address some of the issues that are typically there, like rank reversal and many other things. Easy to compute. Computational demand is higher on this one, and lower computational demand for geometric mean, and then also can address few of the issues that are there in other methods. So priority vector we compute for criteria, and similarly same exercise is done for alternatives. So depending on the alternatives, m cross m, so n pairwise comparison matrices, because each matrix will be with respect to a criteria, and there are n criteria, so those many comparison matrices would be there. So therefore, you can think of the requirement from the decision makers is slightly on the higher side. Consistency check, again same kind of process, and then we do the scoring. So local parity vectors for alternative, just like for the criteria, similarly for alternatives, and then we aggregate. So we put together, our criteria, priority criteria and alternative priorities. We put together and create a vector, and we arrive at global alternative priorities. So now let's take a problem, location allocation problem. So let's assume that a firm is trying to identify the best site out of 6 possible choices in order to set up a production facility. So let's say n is equal to 6 possible choices are there. So those many alternatives. And they have, let's say, 4 criteria, n is equal to 4. Investment cost is there, employment needs, social impact, and environment impact is there. So, based on these, with respect to each of these criteria, we want to apply AHP and find out which one out of these 6 is the best site. So, we look at the Python implementation. So, is this screen visible? The Google Colab screen I'm talking about. Okay. So here, first common import, because many numerical computations would be involved. So we'll do this. NumPy, we'll import NumPy, which is for numerical computation. Now in this slide, I talked about for ASP slide, those slides related to ASP, normalized column sum method was there. So I'll again go back. See, normalized column sum method, eigenvector method, and geometric mean method. So these are implemented. So this is normalized column sum method, this is geometric mean method. So the formula that you see here, the Python implementation of those formula is here. I'll execute this, and geometric mean method. The eigenvector method is implemented here itself in the ASP function. So again, we also need to import this SC from SciPy. So within this, there's we are having this flag C to estimate the parity vector of 1 for eigen. So these are three approaches. So which one we want to use? So this flag is being set here. Okay. And so accordingly, either this one will be executed or this one or this one. And accordingly, we'll be calculating this. Then, for range n, so here you see m is the number of alternatives and n is the number of criteria. So we are specifying mn in this function is right, and we also have PCM and PC criteria. So what are these PCM and PC criteria? So these matrices. So let's say m is equal to 6 and m is equal to 6. So we are doing this setup. M is equal to 6, n is equal to 4. These are random indices for consistency checking. So these are from studies which have done simulations to find out these indices. There are multiple studies. So this is one of them we have taken here. So this is part of this formula that we have here, RIN. Essentially, these are the values for this. So these come from simulations. Then PC criteria, so pairwise comparison matrix of the criteria. So these are the values given by decision makers. So let's say these are the values which we have taken from decision makers. So this array we are creating, this matrix, 4 by 4 matrix, right? Because there are 4 criteria. Then we do consistency check for pairwise comparison matrix. So if CR greater than 0.1, then that means we say inconsistent. Right? So that is not acceptable to us. That means the way evaluations were done by decision maker, they are not acceptable, right? So we can print that message. Otherwise, here also anyway we can print inconsistency index based on these calculation implementation of these formula in Python. Then pairwise comparison matrix of alternatives. So decision makers will also have to do this. Now there are 6 alternatives to this comparison with respect to each of the criteria. PCM1, so there are 4 criteria. So 4 with respect to those 4 criteria, all the alternatives have been compared pairwise, right? And then put it together. Consistency check we do for alternatives. So this is also being done. So all the matrices, all the pairwise comparison matrices, everywhere we will have to check for consistency because it is the decision makers which are humans. They are giving these evaluations. Then we are calling the ST function. Now this is the data, all PC and PC criteria, all alternatives data, and then the criteria data, number of alternatives criteria, and all that is there. And we are calling this function. Right? So this is where here we are computing the parity vector depending on the flag that we have set. So here, let's say C is equal to 1. So eigenvector method would be used. Right. Depending on we can change the flag. Accordingly, you will see the values. So depending on the method, you can have these values, and these are the global priorities, inconsistency index. So everything looks okay here, less than 0.1. So everything okay. So therefore, global priorities can be interpreted, right? And then we can also plot them. So out of those alternatives, 5 seems to be getting a better global score, and therefore coming on top here this way. So so that was it from my side. So if there are any questions, I'll be happy to take.
Thank you very much, Dr. Gaurav, for the very intuitive presentation. It was really, really interesting. And participants, if you have any questions, please. Dr. Gaurav is a very active researcher in this area, so please use the opportunity to post your queries. Okay. Dr. Gaurav, I think you won't mind if they email you with some queries related to the session or any related things.
Right. I'll apply. Right.
Yeah, so you can contact Dr. Gaurav in case you have any queries, further queries. Thank you once again, Dr. Gaurav,
Thank you.
for the time and for the very interesting presentation. It was really intuitive, really interesting. And once again, on behalf of IIITS CCT and the organizing committee, I thank you, and we express our sincere gratitude. Thanks once again for joining us. Thank you, Dr. Gaurav.
Thank you. Thank you, everyone. Thank you.
Yeah, so participants, we'll start our next session soon. So we have uh, Dr. Samir Saran. Sir is actually currently heading the regional center of ISRO. So it's our privilege to have him with us. We'll soon start the presentation at 5. Please be in the session. Okay. Good evening, sir. We'll just wait for more participants to join.
Good evening, Dr. Arun.
Thank you very much, sir, for being here at this time. It's actually an odd time, so still you are with us. Thank you very much, sir. Thank you so much.
No problem. Shall I share my presentation?
Sure,
We can check
sure,
it.
sir. You can share the phone. Yeah, sure, sir. Sure.
Yeah, is it visible?
Yes, sir. It's visible, sir.
Okay.
Okay, very good evening to all. So we will start the session. So today we have with us Dr. Samir Saran. So sir is, as I told initially, sir is currently heading the regional center, RRC North, New Delhi. And sir is a scientist SG. He was previously with the IIRS, Indian Institute of Remote Sensing. Sir is an expert in WebGIS and geodatabase, geodata modeling and processing. He's having years of experience in this field working in ISRO. So, sir is having his PhD in geoinformatics, and he's having a number of honors and awards to his credit. He got Indian National Geospatial Award 2011, ISRO ASI Team Award 2009, ISRO Team Excellence Award, Certificate of Appreciation 2008, and many other awards. A lot of them are there to his credit. Also, he was the program coordinator for geoinformatics. He also got NAEB Fellowship, DOS, DBT Fellowship, and many more. So we are really lucky to have him with us today. Thank you very much, sir. It's really kind of you to accept our invitation and be with us. Actually, like I told initially, it's an odd time from 5 to 6. However, still, despite of your busy schedule, we know that you are currently heading that regional center. So you are busy. So despite of that, you kindly agreed to be with us. Thank you once again, sir. On behalf of participants as well as IIITS CCT, and on my personal behalf, I welcome you to this session. And thank you from my heart. We express the sincere gratitude. Thank you once again, sir. Over to you, sir. Thank you.
Thank you, Dr. Arun. I think I'm audible to everybody. So maybe I'll switch off my screen just to avoid the network issues. So now I'll share my presentation. Screen is visible to everybody?
Yes, sir. Screen is visible.
Yeah, thank you so much. I once again thank Dr. Arun for giving me an opportunity to interact with you on a really emerging area, which is supply chain management. And here I would like to share some of our experiences. And recently we have also initiated a course on supply chain because this area has got a lot of potential, especially in the field of geoinformatics or geospatial technology. Now, the overall outline of my presentation, I think I don't have to dwell more time on the supply chain management because I could see the overall curriculum where the supply chain has been taught in various topics. I'll touch upon some basics of geospatial technology, what are the different stages of supply chain management, and how this technology can be useful. Primarily, the role of GIS in supply chain, right from the beginning to till the end, how this technology can make the difference towards the overall supply chain. There are a few use cases which I'll be dwelling upon and try to emphasize that how the overall supply chain can improve if you make use of this technology. There are few slides I've kept towards the way forward where the role of AI MLDL as well as big data can make the difference, and then I'll conclude. Now, coming to the supply chain management, I think we already know that the overall the movement of the flow of goods and services are the basic primary ingredients where the overall supply chain from raw material to the customer can be taken care. So basically, if you look at the overall scenario from point of origin to point of consumption, that is the basic concept of supply chain. And if you look at the overall stages, there are various stages where the intervention of different type of technologies can be taken care. Now, right from raw material to supply to processing units to finished products to distribution center and ultimately customers. Now, these type of supply chain, whatever the chain, what you see over here, it depends upon the type of material we are working on. So there could be some detailed supply chain, or there could be some areas where the supply chain model could be a little bit less network. So overall, if you see the custom demand satisfaction by right product in right time at right place is the need of hour, and if you make use of these technologies, they can provide different solutions. Geospatial technology as a whole has a lot of potential, right from the overall capturing of the data. If you look at the geospatial technology, we primarily work on the gathering, storing, processing, and delivering the geographic information. Or especially reference information. So if you look at the overall geospatial technology, there are certain pillars which governs the geospatial technology. The first is the remote sensing, that is the Earth observation system, wherein you have satellite remote sensing is the primary source of the data, and how we are providing these data sets at various resolutions, right from different type of spectral resolution, temporal resolutions, as well as radiometric resolution. So these resolutions, because of the different electromagnetic regions, they can provide very important output towards the supply chain. So we have plethora of satellites available. Of course, from India, we have ISRO has a series of satellites which provides different type of application. And apart from that, we also have satellites from the world community. Even there are satellites which are providing the open access data, which you can use it for different products. So the accessing the remote sensing data, either from India or from abroad, is not at all a challenge. And here, if you make use of these data sets directly in the supply chain, it can really make the difference. Of course, there are some geophysical products which are available within the different organizations, like for instance NRSA, the National Remote Sensing Center is providing various type of geophysical products which can directly be used for various applications. Then we come to GIS. I think GIS is the backbone of the overall supply chain because it has a potential to integrate all type of spatial reference data. And once you integrate these data sets together, and what I mean to say, integration means you are overlaying these data sets together, they can provide you some new information which can directly be used. So GIS has a potential to, it's more of an umbrella where you can have remote sensing, GNSS, everything get together, and you can ultimately generate new value-added information. GNSS has a lot of potential. The reason being is that I think everybody knows GPS, Global Positioning System, which is being used by almost everybody. And in fact, if you have everybody is having a smartphone and they have GPS enabled. And because of this GPS, you can do the location, you can do navigation. All this positional information can directly be taken through GNSS. So if you integrate these remote sensing GIS, GNSS, they become important information in order to provide any type of inputs related to any stage of supply chain management. In fact, there are field sensors, which generally people are making use of IoTs, or let us say different type of sensor web in order to do the value addition to the data which is coming. In fact, if you have the in situ measurements from these sensors, they can really validate your data sets, and it can provide you a better data quality with respect to the outputs. ICT anyway has a mechanism to disseminate the data, the mechanism which is being used to communicate different type of information is the role of ICT. So overall, if you see geospatial technology, whether you talk about remote sensing, whether you talk about GIS, whether you talk about GNSS, or let us say field sensors, everything put together can provide you a solution where you can ultimately provide a better decision making. Well, coming to the concept of geographical information system, I think This is not new concept, because you might be aware that the overall concept of geographical information system was evolved way back in 1854 when John Snow, in fact, he made a study on the London cholera outbreak, which ultimately helped him to find the reason behind the cholera outbreak. And that was nothing but the GIS concept. He overlaid both the maps together, and he could find that the water pollution, the contaminated water from the pump, was actually responsible for that. And that was the concept line of GIS. And you'll be surprised to know almost I think 1960 we could get the Canadian Geographical Information System. So that was the history behind it. And from 1960 till date, I think GIS is having more and more applications which are governing the overall decision making. So if you look at the GIS, in fact, everybody knows about it. I think it is more of a system which allows different set of capabilities, whether you talk about geospatial data inputting, how you are managing those data sets, how you are manipulating, and ultimately the output and visualization. All these different type of stages, once you have these data sets in the geospatial domain, you can really play around and you can get some useful information which you might be looking for. So there are, I think, ways and means to create these geographical information with the help of with the help of GIS. When we talk about the characteristics of GIS, I think it primarily governs the location where you have the latitude, longitude, irrespective of its boundaries. In fact, whether you talk about point, line, polygon, any discrete phenomena which is happening on the ground can directly be data models which are being used to capture the real world phenomena. And once these real world phenomena are being captured, you can attach different type of information. One of the important component of GIS is a non-spatial data, where the characteristics, or I would say the quality of the spatial data can be embedded into it. So once you have the spatial data where you have the location information, and when you attach a non-spatial data which could be an infinite attribute, and these infinite attributes makes a data so unique, means you can create a number of maps on the basis of these attributes. So that is the beauty of geographical information system. And there are certain key properties like where, what, how, and when. All these where means you are talking about the spatial location, where it is located, what is that entity or how it is related to another entities, and the time stamping, that is when it is going to happen. Now, if you address all these W's and H, you can really provide the important inputs which might be used for the supply chain. There are certain toolboxes like set of tool systems, information systems, which are being evolved over a period of time. In fact, for the supply chain also, one can really create a dedicated tool, or I would say a decision support system, where the GIS technology, GIS concepts, or let us say GIS basic capabilities can be embedded, and one can really develop the very specific DSS for the supply chain. In fact, if you talk about the database part of GIS, it is, I think, one of the most strongest part of GIS. Why? Because database management system, once you store any type of data, you have to make sure that the data is organized, data is it can directly be updated, and also one can provide the archival system, means if there is any failure, it has to be retrieved at any point of time. Manipulation analysis, if you talk about, I think this is also an important area. Why? Because once you have these data sets, you have to really make sure the data can be manipulated depending upon the different type of operations you want to do. Like there could be an operation which might be related to queries. You can directly put SQL queries on these data sets, and also the topologies, the different type of the operations, either it's the raster data or a vector data, you can do all these type of operations. And once you are operating these operations on the input data, you can manipulate these data sets. Manipulate in the sense that whatever the outputs you are looking for, it can directly be, you will get directly the solution if you make use of the inbuilt capabilities which are there in GIS. The last one is the how you can develop the decision support system. I think this is one of the important area where one has to really put effort and by understanding the requirement. Once you understand the requirement, the decision support tools can be built over top of GIS so that you can have the dedicated applications developed. Well, I told you that GNSS is also another important component of the overall geospatial technology. Because we are always looking for a location. Because I think in this real world, everything corresponds to location. And once this location is captured with the correct accuracy, it can provide you important, I would say, inputs for developing any type of application. So basically, GNSS, when we talk about, either you talk about GPS, or let us talk about Indian Regional Navigation Satellite System, also known as NAVIC. These two provides the mechanism of the best possible data which can be used for navigation as well as positioning. It also provides position, velocity, and time in the same reference system on a continuous basis. So you can see that different type of satellites are all across your Earth, and one can make use of these satellites to capture the location. Whether you are taking the location from GPS or you might be making use of RNSS, IRNSS. And then you have GIS and then supply chain management. I think I'll be talking more in detail on the supply chain because every stage, whatever you see in a supply chain has got direct relation with geographical information system, or I would say more of geospatial technology. There are different applications which are governing, that is GPS GIS integrated system. Whether you talk about automobiles, because these automobiles, I think if you look at most of the use cases, they are governed through automobiles. So if you have a better management of automobile, then the overall supply chain can be better optimized. Whether you talk about fleet management, whether you talk about dynamic vehicle routing, tracking rental cars, online food delivery. I think this is a classic example what we experienced here in the last couple of years, where you could see that the application of these GPS GIS integrated system, like for instance Ola, Uber, or you talk about Zomato, Swiggy, all these are governed through these automobiles where the GPS technology as well as GIS technology is being used, and one can even monitor it, how the overall supply chain is working. There are airline safety mechanism where aviation security is also making use of this GPS GIS integrated system. Agriculture anyway, tracking livestock, yield monitoring are some of the examples where these integrated systems are being used. Ship routing and management, transportation, sea routes, oil tankers, all these every aspect of routing, whether you talk about the routing over sea or you see routing on the roads, everything is governed through GPS GIS integrated system. Law enforcement, like tracking criminals, appealing speed over tickets, and there are so many other areas where these technologies are being used. In fact, the railway tracking system is also taken care by making use of this technology. And in fact, our Delhi Earth Station has developed this model, and they are providing a real-time information for railway tracking. So what I mean to say is that in every aspect of supply chain, you will come across that this technology is being used. Agriculture is one of the classic example. Farm to fork or cow to consumer is a classic example where how the raw materials can be geotagged. In fact, the geotagging of the raw material is one of the most important part. Like I have mentioned, that geotagging of cattle or irrigation advisories. PFZ is also a good example where potential fishing zones have been done with the help of the satellite data, and how the one can really provide the routing where you can identify the potential areas where fishing can be done. Even the crop yield estimation is also done with the help of satellite data, and of course the UAV-based pest management. So all these areas where the important part is the raw material and how we can make use of this sector technology. Even construction and mining and all these different type of applications one can make use. In fact, there could be a more number of use cases where the raw material mapping of the raw material is required with the help of this technology. The processing units, I think if you consider any of these examples, the processing units plays an important role. The location of these processing units has to be identified, and once if you are not satisfied the way the products is being delivered, then you can really reorient, or I would say relocate those processing units with the help of this technology. In fact, there you really have to see that what are the constraints in order, which is the constraints with respect to the distribution of the overall product to the consumer, and it has to be studied in detail so that the best possible allocations can be taken care. The another important point is the mapping, modeling, as well as monitoring of location-based information like maintenance of machinery downtime, labor issues, geopolitical unrest, medical emergency, and natural disasters. There are so many areas where you can really touch upon and see that how these areas, these information can be improved further. Finished products, whenever we talk about, I think we have a very strong supply chain of, whether you talk about Amazon or you talk about so many other agencies who are working with the actual supply chain. So in fact, whenever we talk about location and status of vehicle, in fact, you'll be surprised to know that the traffic management is one of the biggest problem of most of the overall, I would say, supply chain, because you can see that the delivery mechanism, because the product has to reach to the consumer in the least possible time, or I would say a specified time. But that is not happening, and maybe in most of the cases the traffic congestion is an issue. So now people are trying to work on the overall delivery mechanism by making use of drones so that they are able to deliver the product right on time. And in fact, there are mechanism of developing a digital surface model of very high resolution so that you can your product can be reached directly. Even in medical emergencies and all, they are trying to make use of these technologies. In fact, the possible traffic blockage, if you are aware of the historical data, like you might be aware of the traffic congestion which is directly shown in Google Maps. And in fact, most of the traffic congestion is taken from the historical data, and there is some input from the real-time data also. So once you understand your routes where you probably see that there is a possibility of traffic blockage, you can reroute this. So all these things are has to be managed well in advance so that you can provide your services in the least possible time and with full perfection. So multi-depot and multi-delivery location transit network solutions are also being practiced. In fact, the distribution centers and customers, I think this is also an important area where the location of the outlets has to be revisited, and you have to see that how much load is overall monitored in those outlets, so that once you have these data sets available with you, you can really develop the best possible, or I would say where you have more consumers, you can relocate those outlets. In fact, the identification of best outreach. Yes. Hello.
Sorry,
Am
sir.
I
I think
audible
it's
to
some
everybody?
disturbance. Yes. Yeah.
Yeah.
Sorry, I think someone got
And,
unmuted unknowingly. Yeah. Okay.
yeah, no problem. Now, location-based advertising is also important, as well as remapping of chain are some of the areas where one can work on. Now, supply chain asset digitization is an important area, because the most important thing is how you are making your asset digitized, and there are ways and means to do it. As I told you, that satellite images provide you the best mechanism to digitize your overall different type of stages where geospatial locations are involved, whether you talk about spatial data or you talk about non-spatial data. And in fact, the geotagging of most of the services has been initiated by most of the agencies, whether you talk about private sector or government agencies. They are trying to geotag each and every areas. In fact, very soon you will be seeing that the digital address of the particular area will be available, and even the people are talking about the blue Aadhaar, where the Aadhaar will also be linked to the locational information. So what the main objective of these things is that if you are able to asset your digitization by making use of these technologies, it can really make the difference. Only thing is how you are, what means you are geotagging, whether you are making use of satellite images, or you are making use of field data, or you are making use of postal address, paper maps, land surveys, websites, mobile-based field data collection. I think people are really practicing the mobile-based field data collection at this point of time. In fact, there are open source tools like ODK, Open Data Kit, where it is freely available. You only have to create your forms in ODK, and you are able to create the geotagging of those data sets. In fact, VGI and crowdsourcing, the voluntarily geographic information and crowdsourcing, is one of the best practice. In fact, OpenStreetMap is one of a classic example where these type of technologies have been used, and they have tried to digitize the or I would say the updated the road database by making use of this technology. And there are in fact a different mechanism to create these data sets. And once these data sets are created, you can really make use of the existing technology. I was just thinking, I was just browsing the overall schedule. In fact, there the multi-criteria decision making is also being used for ultimately creating the best site suitability analysis. So there are techniques where you can create these data sets, you can analyze these data sets, and once the data, or I would say asset, is digitized, it is easy for you to manage your overall supply chain, which can provide you a better mechanism. In fact, networking analysis models, I think they are not being used properly. In fact, I think everybody knows about the Google the way to optimize the shortest path by making use of various algorithms, routing algorithms like traveling salesman problem, or vehicle routing problem, or location routing problem, or minimum spanning tree. So there are various algorithms in order to optimize your routing. Now it all depends upon the type of impedances you are providing to these networks. So once you provide the impedance with respect to traffic, with respect to distance, with respect to let us say what we can say, like eco-friendly. It all depends the type of impedances you are providing. And once these impedances are fed to these networks, they can provide the optimized route. So you can see that the shortest route for vehicle routing is one of the classic example. Vehicles located at central serves a set geographically dispersed customers, and even you can make a service area like if you have a product, which area it can serve. So those type of service area networks can be established, and once these service area networks are established, you can provide the services. So this way you can optimize your resources, you can create different type of warehouses where the distribution of the data can be done. So everything is possible if you make use of the networking analysis models, which are quite interesting, and one can really make use of this. Spatial analysis, GIS, as I told you, that it has got a lot of potential. In fact, whatever assets or you have digitized, you can further visualize them. You can further do the analysis. You can think about the forecasting system. You can the forecasting of demand and supply. You can optimize your distribution network, and then you can provide the probable areas where these type of demands can come. So there are all the different type of techniques are already available in GIS where you can develop these type of dashboards. And the most important thing is the advanced visualization and analytics, because if you have these data sets, and that too historical data, you can really analyze that which could be a probable area where these type of whatever the gaps you are visualizing, it can be taken care. So real-time tracking and planning, demand and supply forecasting, distribution network optimization, risk management and mitigation. All these are various spatial analysis can be directly applied on this. Because when I talk about spatial analysis, it has got multiple areas where you can improvise these analytical tools, and ultimately this can provide you a better mechanism of information. So visualization and dissemination is another area where once the data sets are available, the dynamic visualizations can directly be done, like whether you have an adaptive symbology or you talk about link and brush technique, atlas generation, all those things are possible. The important part is that if you have these analytics dashboards, if they can be developed, because why it is important, because these type of dashboards can only be developed if you are working on a multi-dimensional data, because multi-dimensional data allows you to roll up a breakdown equation, because these and then analyze these different dimensions, you can really understand the overall behavior of the supply chain. That is the beauty of making use of these analytic visualization, which can provide you a better mechanism. In fact, there are ways in order to really understand the requirements. In fact, the indoor and outdoor logistics is one of the important area. The indoor is quite difficult because you don't have GPS accessibility. You have to navigate from one point to another. So you have to make use of these 3D models. And when you talk about the multi-scale modeling in 3D models, OGC has already given you a mechanism of doing multi-scale modeling, whether you talk about LOD1, LOD0, or LOD2, or 3 or 4. It all depends upon the type of 3D modeling you want to do, which can ultimately supplement your supply chain. In fact, the indoor is more limited to LOD4, where you are doing the indoor navigation, or let us say whatever the information you have in within the 3D indoor, you are able to navigate and you are able to provide better solution. So 3D is an important area, and you can see that solar energy simulation of a building, which may not relate directly to supply chain, but just give you an idea that how the different type of simulations can be created, which can give you an idea. On the right side, you can see traffic noise modeling, which we have simulated by making use of terrestrial laser scanners. The overall 3D models of the building was created, and then we have also tried to add the traffic noises from various two-wheeler, three-wheeler, four-wheelers, all these different type of vehicles was integrated, and we developed an empirical model which can simulate from right from in the morning till the evening. And this simulation ultimately helped us that there are few peak hours where we have to really see that how the traffic congestion can be avoided. So these type of studies can really make you understand that how the logistics can be managed properly, and you can ultimately provide a better way. So 3D indoor mapping as well as 3D outdoor mapping has an importance right from the distribution to the raw material, to overall everything. I would say that it has got significance in all the stages of the supply chain. So this is a classic example of the dairy development in Dehradun. I think this is one of the biggest problem where the amount of milk which is produced is, you can see that 48 lakhs liter per day milk, 14 lakh milk animals are there, but they are unable to distribute this milk all across the Uttarakhand area. Why? Because of they don't have good milk chilling facilities. So you can see that only 2 chilling facilities are there, and if you compare it with Meerut, they have 2.5 LLPD, whereas in Dehradun, in Uttarakhand, only 0.1 LLPD is there. So these type of limitation of resources can ultimately can be solved if you have the entire assets digitized, and then accordingly you can provide better solutions. There are issues not only related with the how the distribution of the milk is happening, but also the overall fodder, how much fodder is available, whether they have the fodder is available with all the domestic animals. The cattle development also, the geotagging of the cattle development, milk chilling facility, transportation, all these are limitations. But once you map these, all overall fodder development can directly be mapped by making use of satellite remote sensing data. You can even find new areas where these kettles can be they can make use of this fodder. Similarly, the geotagging of the overall like they are having a problem with respect to different type of diseases. So all those things can be handled if you have a proper database. And one can even make use of AHP, that is analytical hierarchy process, which is a multi-criteria technique, to identify new areas where milk chilling facilities can be done. And that is only possible if you have all the data sets available and you are able to provide them in a best possible way. IoT-based monitoring of plant, vehicle, driver, everything else, you can make use of it. And GIS-based facility remodeling as well as transportation can be taken care. Well, here I would like to show you one classic example of the COVID-19 pandemic. In fact, this is a visualization platform which Johns Hopkins has developed. It is a bit old actually, but the idea of showing these type of platform is, here I can see that where the COVID cases are there, what is the status of vaccination, which country has already whether they have reached to the sufficient level of vaccination to the individual. So the overall status of the pandemic I could visualize by making use of these dashboards. So similar type of dashboards can be developed on a supply chain where the real-time information is available to the actual owner. And once the team have an overall understanding, you can develop how the location allocation can be done. This is a classic example of COVID vaccine and other health-related supply chains. So you can see that whatever the different type of health facilities are available, you can monitor them and see that whether we are able to provide the sufficient vaccine or let us say medicines to those areas. So all these supply chains has direct linkage with the geospatial technology, and once the assets are digitized, you can really monitor them and you can provide the best possible services. I think I can skip this utility network. So overall success story, I think one of the success story of Dabbawala in Mumbai, I think everybody knows about it. They are supplying around 1,75,000 lunches every day, wherein around 5,000 Dabbawalas are involved. And this is one of the best supply chain considered to be maybe in the world. And in fact, these type of use cases have been demonstrated in most of the IIM institute, that how the mechanism, how the supply chain, and that too, they are not making use of any technology. Rather, they are only dependent on the simple, they are making use of railways and how the distribution network they have defined. So this is and the important thing is, if you apply a digital mechanism, if you apply this technology with them, so I think they'll be able to even supply double the number what they are providing at this point of time. So the thing is that if you have these type of mechanisms, you can really make use of this. Supply chain challenges in pandemic was disastrous. In fact, most of the agencies, whether you talk about any industry, they had a major setback because of the supply operations was stopped, and there was a breakdown in their most of the supply chain, and which has ultimately resulted in low economy. There are challenges in traditional approaches, like one has to really optimize their resources, see that what are the best possible warehouses I can put. I could reallocate my warehouses where the maximum demand is there, so that I can avoid the traveling of the resources from one point to another. The warehouse optimization is always important, because if you are dealing with any product which has to be delivered right on time, it has to be really studied in detail, and you have to see that what are the best possible mechanism by which I can optimize the resources. So warehouse optimization is always a challenge, and it's not easy to optimize the warehouse, because you are linked with so many other because manpower, accessibility. There are so many other issues which are directly linked to the warehouse optimization. So I think that in coming years, or let us say, I think most of the agencies are already making use of the artificial intelligence. And if you have good amount of historical data, because the important part of this type of technology is historical data. And once you process, so that I can provide the best possible mechanism to provide our product to the customer. Big data is always there with these type of applications, because if you have historical data, not only in the form of structured data, it could be in the form of unstructured, or let us say semi-structured. Once these data sets are available with you, you should know how to process them, because they cannot be processed on a traditional or let us say conventional system. You need to make use of Hadoop network or framework, where you can provide the best possible way. One important part is that the data quality is one of the most important part of these type of supply chain, because if there is the veracity of the data is not good, or the data quality is not good, then you have to compromise in the overall output. So you have to make sure the veracity of the data is taken care, because once you are considering the historical data, the veracity plays very important role. And why veracity? Because you might be accessing a lot of information from the social networking data set, and these social networking data sets might have inaccuracies inbuilt into it. So you have to see that how big data can be cleaned or pre-processed, and then accordingly you can make use of these technologies. So there is a possibility that you might make use of the deterministic models, wherein you try to train your data and see that the existing outputs are available to you, and you can look for the probable solution. So deterministic, I would say, is more of a simple approach, where you are already aware about some mathematical computation, and you can generate the output. But probabilistic future outlook is important, because once you have the historical data available, you can understand the model, you can program your model in a better way, so that the accuracy can be enhanced. So there are applications of big data in supply chain operations, right from delivery to inventory planning, to distribution, to demand forecasting, warehousing, scheduling. So all these different aspects have a big data component into it. And if you are able to address all these information in a better way, you can really optimize your resources, and you can provide a better mechanism. So basically, you have to follow a three-step process. In the first step, you have to understand the overall supply chain, how you are providing the different raw material, how you are distributing to your consumers. See that what are the different bottlenecks related to the supply chain. And once you have all these data sets together, you can develop a platform where the AI can be used, which can ultimately provide you a better mechanism of the output as well as delivery. So there are many benefits related to AI ML towards supply chain, whether you talk about decision making, whether you talk about transparency, whether you talk about the real-time delivery or warehousing. In every component, AI ML on top of GIS can be directly used in order to benefit the overall supply chain. So I think whatever things I have told you in this lecture, right from the data inputting to database management to manipulation, and in all overall forecasting, warehouse management, optimization, everything you can make use of the open source software, right from data creation, database management, mobile data collection, 3D visualization. Everywhere you can make use of open source software. In fact, there are dedicated softwares which have been developed on supply chain, but they are more of commercial software. But if you really want to make use of the open source, you have to make use of different type of softwares which can provide you different type of I would say operations, desktop, web, database, and they are compatible to OGC and ISO standards, because once they are compatible to OGC standards, the interoperability between the systems become it is better for you to exchange the information. So there are so many softwares which are being used in supply chain. I will not go into the details. So in the end, I would like to conclude that you really have to see that how the key performance indicators can be evolved with respect to supply chain. In fact, the geospatial technology, as I told you in the starting also and in the middle also, that geospatial technology can make the difference. If I think most of the agencies who are successful in their supply chain are directly or indirectly making use of the geospatial technology. And in fact, there are many startups who are working in this area. They have initiated their overall model that how GIS can directly be used for different type of supply chain. There are many GI tools, like I have told you, that 3D indoor or virtual reality, real-time tracking, all